Alright, this part here is a bit that most of you people who are serious about using this system would have been waiting for, and that's actually exporting the damn data. There's a few different options that we have at our disposal. This guy here, for example, is an inspection points. We have inspection lines, polylines, circles, rectangles, and extensometers. Points are very, very useful. I'm going to say I'm interested in a point, say here. And what you can then do is, just by hitting the extract button, or selecting the point of interest with your hand tool and then hitting the extract button, this will actually output a file of the variable you're interested in, the variable you're interested in here, v in this case, or we could have vyy if we wanted to, whatever you want. I'm going to stick with v because that's just what we've been doing so far, against the file number. Now, if you're taking other data with these photos, which you most likely will, your file number will then be able to be correlated back to force data and that sort of stuff. So you can then use these to go stresses versus strains and all the other fun things that engineers do. That said, there is actually a data acquisition system which we're meant to have with this system, which seems to have gone missing. So it should be as easy as actually plugging our load data into this system, but I'm going to have to work on that down the road. So yeah, we have to do it this way. Alright, so file number against our variable. I can save the plot, or we can save the data. Saving the data is the one that we're interested in. Now I've already created a folder here for data export, and I've created a file. Don't do it this way. I'll get to that in a minute. Alright, first of all I'm just going to say 0.0v, because why not. Save. Now if I have a look at that, sorry, I was actually wrong. It outputs every file, every data point. So you've got all your major strains there, or your principal minor strains there, shear strains. V is what we're interested in. The only thing it didn't output actually was X, Y's and Z's because we don't really need them. And you can see I've got a set of numbers for each data point. For each photo, set of photos. Don't save. Now when I hit save data, okay. That's what I'm looking for. Extraction. What we output is actually determined by this extraction tab, and I forgot about that with the dots, so my bad. So yeah, select what you need and bang. Now, lines are also very nifty, but they've got a couple of quirks which you'll want to know about before you get too stuck in your data. Now what I'm going to do is I'm just going to draw a line, say, let's go this way, why not? And then I'm going to hit the extract button. Now what this is now giving me is V against a point index, and it's just, all it's done is it's equally spaced a number of data points along this line. In this case it's saying there's 101 equally spaced points from there to there, and that's the data that I'm seeing, so that's V that I'm seeing effectively, which makes sense when you look at that data. Now the trick to this is, well, obviously you can change that number to whatever you desire, but the trick to this is when you hit save data, you're best off in rows, and you're definitely best off only choosing one variable at a time. This is where I was getting confused with the other one, which can output all of them and it doesn't really matter. I'm just going to output one variable here, so I'll say v OK, and I'll give it a name. Export it, oops, not videos, I want it in data export. I'm going to say line 0v, this time v actually means something, I'll have to change that v to, because that's meaningless. Save. Now, actually I'll just get rid of that v now because that's silly. Oh, sorry, not that one, this one. I'll get there. It's been a long day, alright. Now, do it this way, don't do it this way. Why is this so? Well, let's have a look at our data that we've extracted. Now, I organised it in rows because it's giving us every data point along that line in one row. Every data point along that line in one row. And then subsequently, each set of images it's giving to me all the way down to 231. And so when you're graphing data, you're generally graphing it that way against the data that gets output from our data acquisition systems elsewhere. This saves a lot of hassle. Put it in row format. Now, why do we only spit out one variable at a time? There's a little clue here which says, number 0v, number 1v, number 2v, number 4v, blah blah blah. Have a look what happens if you spit out more than one. In this one, which I just did earlier, I asked it to spit out u, v, and w all at the same time. What's going on there? There we are. So now look at this. U, v, w, u, v, w, u, v, w. Trying to sort that data out will be a nightmare. Yeah, the larger the data file, the more likely it is that you're going to want a macro to do it, because it's just going to get ugly quickly. For the sake of your own sanity, one variable at a time. Don't save. Now just to show a couple of other things. Now a polyline is exactly the same as the line tool, except your line can go in various different directions. Circle is also the same as a line tool, except it is now in a circle. I don't like that particular circle function though, because it defines a circle from the center. And in our case here, there's actually a hole in the center of our specimen. I would like to define the center as the circle, as the center of that circle, and bring it out to here so I can get strains all the way around. But the software doesn't allow you to do that. It wants the center point to be on valid data, and so yeah, I just find it a bit awkward. Now you can also, oops, sorry, that's not where I want to be. Where's my data? There, that's that circle tool there is what I'm saying. Rectangles, same thing, it's just the same as a polyline, but whatever. The last tool that I'm going to talk about here as far as extracting data is the Inspect Extensometer tool. When you click on that, you're asked to select between 2 points. I'm just going to choose two sort of randomly around here. Then when we go to extract our data, we get given a couple of options. Now, DO, it's not very obvious here, I actually had to sit down and work it out a little bit. DO is actually the original gauge length of the 2 points that I selected, which the 2 points are about 0.6 millimeters apart, 0.7 millimeters apart. You see that doesn't change. D1 is the final length at each image of the extensometer. And so we started off with about, what did I say, 62.7. And you see our very first point there is about 62.7, and then that grows from there on in. And so therefore, delta L is D1 minus D0. So delta L is the change in length. And so E, which is your strain, is change in length divided by original length. You can see it's exactly the same graph. E should really be epsilon, but anyway. So it's 0.22 strain at maximum. So that's quite a lot of strain at its final points, which I suppose makes sense too, because at its final points, that specimen's actually failed. There's a big crack in the middle. So it's not technically a strain, I suppose, but nonetheless, that's how we're going to interpret it there. We hit save. Let's have a look at extraction first. Now that's actually going to output each of those variables as is, so we're just going to say, yep, okay, extract and save. Again, we put this in our data export, and I'm going to call that extensometer. I can never spell that word. Ometer 0, and I'm outputting it all, so just call it that. We'll have a quick look at that data. Extensometer 0, and you see gauge length, original length, final length, change in length, and strain. So, beautiful.